In this video, I want to try and answer the question, why should we invest in our heating, air conditioning, and ventilation systems? What's the need that the school district has in this area? And obviously that's a tough question to answer because a lot of the things that need improvement are sort of behind the scenes. They're difficult for the public to see. And so want to spend some time in this video highlighting the things that are in the Baker Group comprehensive assessment that was completed several months ago, and try to take you through video up on the roof, into the boiler room, and talk about some of the needs that we have. Specifically needs in ventilation concerns, higher than recommended levels of CO2, temperature control issues. You'll see the temperature variations throughout the district are extensive, and just some of the old equipment that we have that is really near the end of its lifespan and needs to be updated and improved, because we continue to spend a lot of money on repairs annually, and we're just putting money into things that are really being band-aided and are sometimes a challenge to find parts for. And we could certainly improve our energy efficiency, save the district some money in the long run by improving our equipment. And we're going to show you some of those pieces of equipment and some of the behind the scenes things that justify, we believe, the need to invest in our HVAC systems, our heating, air conditioning, and ventilation systems at this time. In this portion of the video, we're going to demonstrate some of the temperature variations that are occurring throughout the high school facility. And to do that, we're actually going to walk around the building into several learning spaces where students are. We're going to take some temperature readings with our handy-dandy laser thermometer that I picked up at the local hardware store. And you'll see that there's quite a variation from what seem to be really cold temperatures for a warm summer day, and then more warm temperatures in just classrooms that are not very far apart. And so that inconsistency obviously creates problems for our students and staff as they have to learn and work in that environment. Okay, before we get started with our temperature readings at the high school, I just wanted to give you a reference point. I pulled weather.com up on my computer, and I think it's relevant to note that it's expected to be 85 degrees today outside, 90 tomorrow. It's September 20th, and I think that's a relevant factor as we look at the inside temperatures in the building at the high school. Okay, we're in the high school office. I'm going to take a temperature reading here so you guys can see what the temperature is on this nice sunshiny day. See, the temperature in the main office here is 61 degrees. Talk to Kathy and maybe ask her why she's wearing a flannel shirt on a day that it's 85 degrees outside.
This is just typical for in the room here. It's supposed to be around 90 degrees outside today. The warmer it gets, the colder it seems to be in here. So this is typical. You need to definitely dress in layers.
Okay, we're in the high school library, and we're going to take a temperature reading in here, and we're going to have a quick conversation with Tess. If she'll come over here, we'll hand the microphone to her, and we're going to ask her why she's wearing a blanket today. So.
It's really cold in the library, and it's hard to work in the library when it's so cold in here.
So real quick, I shot the temperature in here, and you guys can see it's 59.5 degrees in the library today even. Okay, the next two classrooms that you're going to see are going to show you the other extreme of the temperature variation in the high school. The first will be a Spanish classroom, and we'll take a reading in there, and the second will be the vocal music classroom. We'll take a reading in there.
Muy bien. Y para la cena. Nacho.
Nice. Good job. Take a seat, center ones. Good job. Here we go, center twos. You knew. There you go. On the ball. Here we go. Pick up to 80.
While we specifically focused on showing you temperature readings in the high school building, there are no doubt variations in all three buildings. For the sake of time and because there are many other things that we want to show you, we will not take temperature readings in other buildings. This next segment will show you just a couple video clips of CO2 readings in a couple classrooms. The first will be in a high school classroom, and the second will be in an elementary classroom. The CO2 readings, you'll notice, are above the industry recommended standard of 1,000 parts per million of CO2. And I just want to reiterate, and you'll hear our guests from Baker Group explain this, but I just want to make sure that we're clear. This is a concern, and it certainly is not an optimal learning environment for kids when the CO2 levels are too high, but we are not presently in a situation where it's dangerous for kids or for staff. The outcome of the CO2 levels where they currently are might be periodically students feeling sleepy or tired. Same for staff. In the worst case situation, it might result in a headache, a low grade headache for students or staff. But no students are in danger in these situations. And I just want to reiterate that if they were, we'd take immediate action to rectify those situations. But regardless, the levels are higher than we would like them to be. And for kids to have an optimal learning environment, we obviously need to be around industry standard. And so we'll show you those things next.
And throughout the district, we have monitored different classrooms and different buildings, and they all have issues with fresh air, just not bringing enough fresh air into the classroom to help the learning environment. That is something we'll look at now. Outdoor air is typically around 400 to 450 parts per million of CO2, and usually design standard is around 1,000, not to really go above 1,000, and then so we just took that reading and we were a little over 1,200 parts per million. Out in the hallway, we're coming down already to below 1,000. It's not a huge concern as like an emergency. It is a concern in your learning environment. If you get above that, it makes the learning environment difficult, makes kids sleepy, has adverse effects on how well they perform in the classroom. It's not an issue where you're gonna close school for the day, but it is a concern on how well your students perform in the classroom.
If your book is not put away, I'm going to ask you to put your book away. If there's markers out, will you get the markers put away? I'm going to ask you to, I'm sorry.
So we just shot the CO2 levels in that art room there, and that was a concern of mine in our earlier report, and we checked it again today, and the levels were just under 2,000. It is much higher than the design and what code requires. It's not a threat to the children, but it is not conducive to a good learning environment.
All right, we're up on the roof with Jim Cooper and Chris Comier up on the high school roof, and they're going to show you a couple of the systems that we have in this facility and some of the issues that we're experiencing here.
This particular condensing unit feeds the air handler down below for the auditorium. This is the control section. The compressor on the left has failed, as evidenced by this contactor that's blown apart. The unit is at such an age where it's hard to justify putting money into something like this for several different reasons. It's a part start winding compressor, it's R22 for a refrigerant, and the 208 volts we really can't do much, but with the type of system that it is, it's cost prohibitive to put anything more into it considering what's available today for equipment. So the left side compressor does not function any longer. We're running off of one part of the system, which is the right hand side. But this is an example of all the condensing units to show the age and limitations in the life expectancy of this equipment. And it's similar for all the rest of these condensing units that you see up here on the roof.
It's a recip compressor, which the technology is about 25 years old. On this machine, I would expect the normal life expectancy to be about 15 years, and this is close to 25, 26 years old.
The main consideration for the school's long-term budgets as far as maintaining this equipment is these are R22 systems, and that refrigerant's being phased out, and it has been getting phased out over the last 20 years through the Montreal Protocol. Most of the price of the refrigerant is federal tax to phase it out. That's going to further amplify changes needed for this equipment because this is all R22, where once upon a time it was probably 50 cents to $1 per pound. Now our cost as contractors could be anywhere from 30 to 50 depending on what day you're buying it, because every 6 months the price is going up on a graduated scale from the federal government. So that further is going to amplify our concerns for long term for this equipment, of repairing it, keeping it running. We're looking at these Mitsubishi Mr. Slim air conditioners to illustrate the fact of what he's got, and these are not part of like a rooftop unit setup where we get some fresh air These are basically just conditioning the existing air in the room, so that may be a concern. Parts for these have been a problem in the past to get, unfortunately. I don't have a good answer for why, other than the problems that we did have. We had to wait 3 or 4 months just to get a circuit board for one of the other units in Paul's room. So food for thought for these units, long-term reliability is going to be a question, not to mention code for fresh air requirements with these pieces of equipment. So.
Okay, you can see the breakage of the conduit exposing wires, and then on the insulation you can see the UV degradation of the insulation of the refrigerant piping.
We're here looking at another condensing unit that serves the front offices as well as some classrooms. Another example of an older, outdated condensing unit that we've managed to replace 2 compressors in within the last 2 years just to keep cooling for the facility, because our options were limited without it, so that's what we had to do. But very expensive. I hear numbers 12 to 13,000 per compressor. Their parts start winding again, compressors, 208 volt. Incredibly inefficient, but we had to do what to do to get you air conditioning, but we don't want to keep doing it.
This is a pneumatic control panel with old technology. It's pneumatic driven. The controllers are 25 years old. The number of people who can work on this is just a handful, and they are retiring out of the workforce. When these fail, you don't have somebody that's able to work on them. Also, there's moisture in the system that will cause these things to fail. So when they do fail, you'll get room temperatures that are wrong. You'll get things doing the things they shouldn't and consuming more energy when they do it, and nobody's happy.
Specifically, I want to, these are the control pneumatics that control our central office and our high school principal's office, and they have completely failed, and we're in the wide open position. I'll give you temperature readings later, but we're in the low 60s in those spaces because the air conditioner is on all the time, even though the outside temperature may be 85 or 90 degrees.
I'm Brian Schwartz. I'm with Baker Group. I've been working with the Roland-Story Community School District for a few years now. This compressor here is tied to your pneumatic control system, all the controls that control the building, as we talked about earlier with looking at some panels. This compressor will not stop running because of all the leaks in the system. This thing has to keep running to keep pressurization, which uses energy and the cost to fix it. We've had some time spent on this thing to keep it running for the school. It's another Band-Aid as we continue just to keep things going here and at least keep the environment somewhat suitable for kids to learn in.
We're air handler number, I believe it's number 2, that serves some areas down below. This is an example of what I had to do one summer day. We had an inlet guide vortex fail. The receiver controller I found was failed, as well as the position controller of the actuator was failed. So once I made the replace to the inlet guide vortex, I had to put some wire on this actuator to get some airflow and get some relief cooling to the floors down below, because the repairs at that point in time were not possible, practical, or economical, so I had to do this in the meantime.
All right, so here we're looking at multiple systems of both heating and cooling for the school district. The primary is steam, so these are steam boilers. A portion of the building is heated by steam, the oldest portion. The middle-aged portion of the building in the 90s is actually heated by steam, but it's converted to hot water. And then the newest portion of the building is actually heated by steam again. So we have multiple systems that are difficult to maintain, and the age of the system itself. The other portion is the cooling side. We have split system cooling basically parked all over this building. Many different units with a lot of maintenance around those because of the amount of compressors, the many parts to the equipment, just serving a single classroom in one area rather than just a centralized cooling plant. So it's something to look at for the school. There's multiple systems create a lot of maintenance, and they are getting older and they are energy inefficient.
We're in the penthouse of the elementary school building, where this was an original multi-zone system, which probably was from the 60s, and it has failed, and so they've retrofitted it with residential equipment, and putting residential equipment into a commercial application typically is not a good idea. The things they're doing with that have caused some of the system components to fail and be replaced. Okay, we're looking at the the residential condensing units used in a commercial setting. He has 34 of these, which means he has 34 times the equipment to maintain and 34 times the opportunity for things to break, as opposed to a commercial system which would have fewer components and less maintenance.
We're at the elementary school, and we're looking at some of these residential units that are heating and cooling the classroom spaces. These are Lennox Pulses, circa 1991. The reliability of these is getting questionable. It's expect to get about 20 years out of this equipment. We're well over that now. Getting parts to maintain these units is another difficult process, either trying to find them on something like eBay or some knockoff part in China.
At the beginning of this video, I referenced this 50-page report put together by Baker Group, where it highlights our facility needs in the areas of heating, air conditioning, and ventilation. And in the video segments that you've just had a chance to watch, we highlighted many of the things that are in this report. Clearly, we do not have time here to highlight everything. We weren't able to talk about the age of our windows and some of our lighting that is outdated as well. We weren't able to talk about the fact that the temperature readings that we shared with you in the video exist at all times of the day and night. There are no timers on any of our systems that allow for there to be adjustments in the temperature when the building is not occupied or when people are not here. For evenings and weekends and holidays and those types of things. We can talk about the energy efficiency that could be realized with some newer and updated equipment and the money that would be saved in our general fund as a result of having lower energy bills. And so there's a lot more in this report that we weren't able to highlight in this short video segment. I appreciate you taking the time to watch this all the way through. And if you would like to learn more about our HVAC issues that we have, please stop by my office. I'll be glad to let you review the whole report. Give me a phone call, shoot me an email. We'll try and answer whatever questions you have. Please ask questions if you have them. Thank you very much.